Hey guys, this is Mr. Bennett, and this is Unit 13, video number 1. And we're going to talk about the relationship between heat and temperature. So this unit that we are in right now is known as the thermochemistry unit. And what it does is, overall, throughout the course of the unit, we're going to look at the study of heat changes that occur during chemical reactions and physical changes of state. So based on what we talked about today, if we add heat, right, and we know that heat is kind of essentially it's a type of energy that is passed through thermal means. So in other words, hot to cold. Okay, and by adding heat, we essentially give the substance energy, that thermal energy, that will in turn affect the temperature. And we know that temperature is just another, essentially it's a measurement of another type of energy, which would be kinetic energy. So the idea is that essentially your heat is providing the energy that when taken in by the substance will affect its kinetic energy. So if we look at this diagram over here, we're saying that by increasing the temperature, we will essentially take a substance, if it's a solid, to the liquid state. And if we continue to apply heat and raise the temperature further, we will take it to a gaseous state. And we know that this process of going from a solid to a liquid would be melting, the opposite of which would be freezing. Right? So if we were essentially taking the process backwards, we would be freezing it. And the process going from a liquid to a gas would be vaporization. And we know that the opposite process would be condensation. Okay, in terms of what we added to this today during lecture was the idea that essentially the process of melting includes breaking those intermolecular forces that are holding the solid together, and we can refer to that as the heat of fusion. And we know that the process of breaking the intermolecular attractions that are present in a liquid, turning into a gas, is known as the heat of vaporization. Okay. Think of the solid as having the lowest amount of heat, or the lowest amount of energy, and a gas as having the highest amount of heat, or again, the highest amount of energy for that substance. Okay, we also talked about heat in terms of two different things. Mass, meaning that the larger the object, the more heat it's going to take to get the same change in temperature. We refer to this as heat capacity. So in other words, if I have a small pot of water, it's going to take less heat to get, say, I don't know, a 1 degree increase in the temperature than a large pot of water. A large pot of water is going to require more heat to get that same 1 degree increase in temperature. So if we think of heat and its effect on mass, okay, and then we want to think about the temperature change, the fact that we want to raise the temperature by adding the heat. So essentially we have a starting temperature, we'll call that T1. So if it was at 10 degrees Celsius, for instance, and then a temperature that we're going to end up with. And if we're going to raise it 1 degree, then if we started at 10 degrees Celsius, our T2 would be 11 degrees Celsius. Okay, so it's the change in temperature. And typically, when we figure out the temperature change, we're going to want to figure out the difference. So it really comes out being more like T2, meaning the final temperature, minus T1, means that the change in temperature would be whatever number this is. So in the case of our example, it would be 11 degrees minus 10 degrees, which would give us a 1 degree temperature change. Okay, and then the other factor that we talked about today was the idea of specific heat. And what I mean by that is that heat will have a greater impact on temperature change for some substances compared to others. For example, oil, like oil on the stove, is much easier to heat. It heats much faster than water. And it has to do with the specific properties of oil compared to the properties of water. Okay, so it has a different specific heat than water. Now, we talked about essentially the symbols that we use for these different words or terms, and so today in class. And so heat we could call Q, right? Mass, I know we could come up with some symbol for heat capacity, but it really comes down to its mass. So we're going to use an M to represent mass. Temperature change, we're going to represent as delta T. So the delta just means the change. So it means you're going to find the difference between the final temperature and the initial temperature, just like I did up here. Okay, so that's what delta T really is. And then for specific heat, we talked about in class that it's represented by the symbol C. So what that means is we have our equation here for figuring out the effect heat has on a particular substance. The equation is Q equals M delta T C. And so if we get a question, we can just plug in the values and find out the effect. So let's look at an example here. It says how many calories are required to raise the temperature of 30 grams of water from 20 Celsius to 40 Celsius. And then it tells us the specific heat of water is 1 calorie per gram Celsius. Now my trick here is I start off by identifying all of these variables, Q, M, delta T, and C, before I plug anything in. So as I read through, it says how many calories are required to raise the temperature of 30 grams of water. First of all, I recognize this as a mass. Okay, 30 grams of water, that's my mass. And then it says from 20 Celsius to 40 Celsius. Okay, that is my delta T. Okay, and then it says the specific heat of water is 1 calorie per gram degree Celsius. So specific heat, that's my C. Okay, so what's the one variable that's left off that we haven't used? Well, we've got the M, we've got the delta T, right? We've got the delta T, the M, the C. So the thing we're solving for is Q in this particular scenario. And notice it says how many calories are required, and we know that calories is the non-SI unit for measuring heat. It's the unit based on measuring the change in temperature of water. So let's plug these in and see what Q is. So we're going to solve for Q, so Q equals, and then we know M is equal to 30 grams. Okay, and then we know that the change in temperature is from 20 to 40. So in other words, 40 degrees Celsius minus 20, which is going to give us a difference of 20. So I'm going to plug that in for my delta T. Okay, and that's degrees Celsius. Now I'm left with my C. Okay, when I plug in the specific heat, notice it's 1 calorie, okay, per gram degree Celsius. And this is important because this slash here, that's really your line that you would use in a fraction. Okay, so that means that grams and Celsius, we're actually dividing by them here. And the reason why this is important is because when we actually go to solve this problem, notice that here we're multiplying by grams, but here we're dividing by grams. So just like in dimensional analysis, when you have something on top and you have something on bottom, they're going to cancel out. Okay, and here we're multiplying times degrees Celsius, and here we're dividing by degrees Celsius. So that means they cancel out as well. And all we're left with are calories. Notice in the problem, they want calories in the answer. Okay, so if you set this up correctly and everything is in the correct units, then everything should cancel out except for the units that you want. Okay, this is really, really important when they give you say a specific heat that has Kelvin in it or some other unit, but then the units they gave you in the problem are in, say, Celsius. Well, that means you'd have to commit. You'd have to essentially change the Celsius into Kelvin so that the units would cancel out. Okay, you have to have the same unit for temperature throughout the entire problem. You have to have the same unit for heat throughout the entire problem, and the same unit of mass throughout the entire problem. Okay, if they all cancel out and you wind up with the units you want, you can do the math. So it's 30 times 20 times 1, which is going to be the same thing as 600 calories. Okay, so that's the example. Now what I'd like you to do is solve the practice problem. See if you can solve this one on your own. When you get to your whisk, the last question is going to ask you for the answer to this practice problem. So you're going to plug in your answer, and then once you hit submit, the message that pops up that says your submission has been received or whatever will also have the answers to the whisk questions so you can see if you got it correct. Okay, make sure you do your whisk, and we'll see you tomorrow.